Okay, Vanessa, what did you get as being the biggest perfect square that divides into 72? Haven't got it? What'd you get? 36. Okay, now how do we look for that? Remember our strategy here. Is 72 a perfect square? 72 is?
Oh, no.
No. 72 is not. So then on our list, where do we start looking? Cut it in half, which happens to be right on a perfect square, right? And then if it weren't, then we just keep looking up until we get to the bottom, right? So 36 is the biggest perfect square that divides evenly into 72. So 72 equals 36 times what?
2.
2. Okay, so then we're going to rewrite this as the square root of 36 times the square root of 2, right? Always want to put the perfect square first. Remember that. That's important. Makes it easier to stay organized. Okay, what's next? Dean, where do we go from here? Square root of 36 equals square root of 2. That's not the answer. That's not the form we want. That's the answer. What do you think, Nick? Well, we could, sure. Yeah, we could do that. I mean, I always kind of do that to show. You could either just make an equal sign if you want to. That's fine. What's that going to become? 6, exactly. There's our answer, right? That's the whole point. Remember, what we want to do is get that perfect square, get the square root of a perfect square, because look what it does. It ends up being 6, right? Square root of 49 would be 7. Square root of 25 would be 5. Okay, that's the goal. We want to get we want to try to get the biggest number outside the radical if we can. Get the number inside to be the smallest. All right? Let's try another one. First thing I want you to do is I want you to try to establish figure out for yourself what's the biggest perfect square that divides into 50. Okay, what is it? What's the biggest perfect square? 25. And so then the other factor must be 2, right? 25 times 2. So we get the square root 25 times square root of 2. And Hannah, what do we end up with? 5 square root of 2. Perfect. Okay, good. Okay, next step now. What happens if we have a product? What if we have something like this? What if we have, what if we have something like square root of 8 times square root of 2? There's a bunch of ways we can do this, but let's work through a couple of these, and you can look at your options. What do you think you could do with that? Yeah, what do you think?
So you go the other way?
What do you mean by the other way?
Instead of like simplifying it down.
Make it bigger?
Yeah.
Yeah. So what are you going to get? Square root of what?
60.
Yeah. There you go. Right. So here, that's one option. Sure, you can just multiply the numbers inside the radical. So you could get this to be square root of 16. And what are you going to get for that? What is the square root of 16? That's one of our numbers, isn't it? One of the perfect squares. 4. Yeah. Very good. Okay. That's one way to do it. That works great. Okay. Another way you can do this, and you can always, let me emphasize, you can always fall back on that. You can always just multiply the numbers inside the radical to get a big number, just one big number, and then deal with it like we did all the other ones, okay? You could also do this, though. Could I simplify this one by itself? Is there a perfect square that divides into 8?
No.
Jeremy, can you think of one? Perfect square that divides into 8.
Oh, 2.
2 squared, right?
Yeah.
So 4, right? Okay. So we could break this up into the square root of 4 times the square root of 2 times the square root of 2, right? Okay, here's the trick. The square root of 4 is what? 2, right? So we know this one's going to just become a plain old whole number 2 times. Now what's going to happen with those two?
It can.
Yeah, the square root of 2 times the square root of 2 is the square root of 4. So what's that going to end up being? 2. Okay, but you don't even have to go through those steps. You just know that any time you have a square root, like if I had the square root of 31 times the square root of 31, what do you suppose the answer is going to be? What? No. If you multiply a square root times a square root, you're going to get inside, you're going to get that number squared. It's going to be a perfect square, isn't it? Right? If I multiply these two together, I'm going to get the square root of some big number, but what is that big number? It's just 31 times 31, right? Another way of saying that is 31 squared. What do square roots and squares do to each other? Cancel each other out, sure. So then that cancels that, and your answer is just 31. So the trick is, anytime you see a square root times itself, you always know that's just going to unlock the square root. Okay? So going back to our problem then, what's that going to equal?
It's going to cancel each other.
Yeah, well, you're going to get 2, aren't you? Right? The square roots go away and you just get 2 times 2, which is 4. Okay, so you've got two strategies. You can either make one big number and simplify that, or you can try to simplify any one of the small ones. I kind of prefer to simplify any one of the small ones, because then you're working with smaller perfect squares. And then just multiply out those factors and see what you end up with. Okay. Try another one. Questions on that first? Okay, let's try one. About try that. I'm going to try it, but first time, let's do it both ways. First time, try it by just getting a big number. Multiplying the two together and getting a big number. Once you got your big number, see if you can then break that down. So find the biggest perfect square that divides into it. Break it down. And that's right. Keep going. Right. Good. Keep going. Find the biggest perfect square. That's good. Okay. So what do we get? What's our big square root? 90. Okay, so now we gotta break that up into a perfect square part. And a leftover part. So what do we get? What's gonna be the biggest, Brayden, what's the biggest perfect square that divides into 90? What'd you get? I mean, you can, what's half of 90?
30. Oh, sorry.
45? And you know what, you don't have to do it that way. If you want to, you can just start at the bottom and work your way up too, that's fine. Remember, if you don't get the biggest perfect square, it's not the end of the world. It just means you're gonna have to go through another step, right? So maybe let's try going this way once. Does 4 go into 90?
No.
Does 9? Yeah, 9 does, right? Okay. So we could break that up into the square root of 9 times, 9 times what is 90? 10. Good. Okay. So now we're done. What is our, this was useful to us. We did this for a reason. Square root of 9 is 3. Right? So that's our answer. Okay, good. What if we should just one little thing here. Now don't let this be confusing. I just want you to see in math you gotta get past that feeling that, oh man, why is he showing me so many? You don't have to do things a bunch of different ways, but you have to see how a bunch of different ways mean the same thing to get good at math. Here's something else we could do. Do either one of those two square roots simplify? Is there a perfect square that divides into 6? It can't be, right? Because the smallest perfect square is what? 4, right? 4 doesn't divide into 6. 4 is already too big. So 6 we're stuck with. What about 15? Does 4 divide into it? No, it doesn't. Does 9 divide into it? No. We missed it, right? So that one also doesn't have a perfect square. But look what we could do with this. I just want you to see that this is also a way that works. 6 could be factored. 6 could be factored into what? 2 and 3. Neither one of those are perfect squares. But I could write this as the square root of 2 times the square root of 3. 15 could be factored also. What does that factor into? Square root of 3 times square root of 5. Okay, now do you notice anything there that's useful? Yeah, square root of 3 times square root of 3, right? So those become, when I combine those, what am I going to get? Right, so I'm just going to get a plain old 3. Square root of 3 times square root of 3 cancels the square root. Whenever you multiply a square root by itself, the square root goes away. So I just get 3. And then what are these going to become when I multiply those together? 10. Yeah, square root of 10. Now does everybody see, this is important, does everybody see that the square root went away here because they were the same square root, but here it doesn't. The square root of 2 and the square root of 5 are different, and so I get the square root of their product, 10, right? Okay, let's try one more of these. Try that. And maybe just stare at, before you jump into this, maybe think about it just a little bit. Now we could certainly multiply all those out like we just did. But you might want to ask yourself, are any of those freebies? Did I just toss you a softball up there? Are there any of them that'll simplify right away? Okay. What do you think? Options.
Becomes it, or you can simplify it all of it.
Yeah, I could multiply them all together. That's one possibility. But can I can make that simpler. Then I get a big number.
Yeah.
What do you see up there right away? There's one trade we can make immediately. What's any of those numbers perfect squares?
No.
4. Yeah, square root of 4 is what?
2.
2. Sure, this one just becomes a 2. This stuff, those are not perfect squares, but what big square root do I get if I multiply them? Square root of 18 times 2. Now we want to flip that around. We want to put the 2 out front. But that's much easier. We've got the 2 taken care of. Now we got to see if we can get something else. We can simplify that square root of 18. What's a perfect square that goes into 18? 9. Right, 9 and 2. Good, so this could become 2 times square root of 9 times square root of what? 9 times what is 18? 2. Okay, so then we end up with 2 times, what's the square root of 9? 3 times, and we're stuck there, right? Square root of 2, can't do anything to it. That one's just left over. 2 times 3 is, that's our answer. Got that. Okay. That's, you know what? We'll practice in the lab tomorrow. We're not going to get down there in time anyway. No, let's go down and get a little practice. We got one last piece of this tomorrow. You want to be definitely. Who wants to be? Anybody want to be requested for teacher access? Have any questions on any of the homework? Okay. Raise your hand if you'd like to be requested. Anybody? Just one? 2? Okay. Okay, hey, I'll tell you where we're going here. So Trevin and Jeremy. All right, so we are headed to okay, real quick, listen up. When we get down there, the first thing I want you to do right away